Hey there guys, Kevin Rick here. In this video, we'll be having laws of logarithms. Why? Because this will be helpful in solving logarithmic equations and inequalities. And this can also be used in evaluating logs. So let's get started. Just like exponential equations, logarithmic equations also has parts. The little number just after the log is the base, and the number next to them is the argument. And of course, we have here the result. So 2 is the base, 8 is the argument, and 3 is the result. Now let's go to the main business. Logarithm of products. This law states that the logarithm of a product is equal to the sum of the logarithm of the factors. Well, it's saying that if we are given an argument and the argument can be factored, we can rewrite it into a sum of simpler logarithmic expressions. So let's try. So we have here one logarithmic expression, and the argument here is 5ab. We can express this as sum of simpler logarithms. How? We identify the factors. The factors are 5, a, and b. The idea is that we can actually rip this apart. We can expand this. We can rewrite it using the factors of the argument. So we have here 3 factors. So we can rewrite this into 3 simpler logarithms. We get 5, and that will be an argument of 1 log. A will be another argument of another log, and B will be another argument of another log. So this is how it looks like if it is expressed as sum of simpler logarithms. We get the log and then the base, and we just distribute the factors of the argument. Now, what if we are given a sum and we are asked to combine it or condense it into one single logarithmic expression? Well, it's the reverse process of this one. Okay, so first step, we identify the arguments. So the arguments here are x, 10, and y. So we get log and then the base, and then we multiply the arguments. So the arguments are x, 10, and y, and if we multiply them, the product is 10xy. Note that we can only apply the laws of logarithms if the bases are the same. We cannot combine logarithmic expressions with different bases. Okay? Let's go to the next one. We have here the logarithm of quotient. Now, quotient, that calls for a fraction. And this law states that the logarithm of a quotient is equal to the difference of the dividend and the divisor. We get the number on top, that is the dividend, and that will be the argument of the first log. We get the divisor, and then that will be the argument of the second log. You see, if that's a fraction, then that is subtraction. So let's try to do this one. You have here logarithm of 2x over y to the base a. That is a fraction. We get the dividend. The dividend is 2x. And then we get the divisor, that is y. Uunahin nating isulat yung dividend. And then minus the logarithm of the divisor to the base a. And the divisor here is y. But as you can see here, 2x is a product and we can factor 2x. So we can expand this further. Since that is a product, well, that is addition. So logarithm of 2 to the base a plus logarithm of x to the base a minus logarithm of y to the base a. Now, what if we are given a difference and we're asked to condense it? Now, this is what we're going to do. If we combine this, 80 will be the dividend and 5 will be the divisor. So 80 will go on top, 5 will go on the bottom. And this is not a final answer because we can still simplify this fraction right here. 80 divided by 5 is 16. Okay, so that is the final answer. Now let's go to the last one, the logarithm of power. This law states that the logarithm of a number raised to a power is equal to the product of the power and the logarithm of a number. Sounds complicated, but this is just how you're going to do it. Now, if the argument is raised to an exponent, you can get that exponent and just write it just before the log expression. Let's try to do that. Oh, it looks creepy. There's a lot of radicals, and I don't want that. But this is a single logarithm, and how are we going to write it as a sum or difference of simpler logarithmic expressions? So let's do it step by step. First, we get the dividend. Whatever on top, that will be the argument of the first log, a plus 2. Since that is a fraction, well, that is subtraction. The divisor, or whatever is in the bottom, that will be the argument of the next log expression. Now, we're not done because radicals are actually fractional exponents. Remember that square root is exponent 1/2. So a plus 2, 1/2. So don't forget square root is exponent 1/2 minus, we have here logarithm to the base x, and we have here cube root, and cube root is exponent 1/3. So we get what's inside the radical and raise it to 1/3. Now we can apply the logarithm of power. If the argument is raised to an exponent, we get the exponent and write it before the log expression. So the exponent of the argument is 1/2. And so now I can write the log expression minus, we get 1/3, the exponent of the argument. And so we can just write here the log expression, a plus 3 to the base x. So that is how we expand that logarithmic expression as a difference of simpler logarithmic expressions. So now we do the reverse process here. Since the bases are the same, we can just combine them together. Here we have here a number before the log expression that will become the exponent of the argument. The argument is x, so we're going to raise it to 3. Okay, so kinuha natin yon, nilagay natin siya as exponent of the argument. Plus, so we have here another number before the log expression that will become the exponent of y. Minus, oh, so 1/2 is a square root. That would be square root of z. Now, since we have here addition, we can like multiply the arguments. So that is x cubed times y squared. We still have minus logarithm square root of z to the base b. Since that is minus, that calls for a fraction, and this will be the dividend and this will be the divisor. So fraction, whatever is written first, that will be the one that will be written on top. And of course, square root of z here will be the one to be written on the bottom. So there you have it. We already condensed this 3 logarithmic expressions into just one single logarithmic expression. So there you have it, guys. Soon, these laws will be applied if you solve for logarithmic equations or inequalities.